webinars in our webinar series and to have, be notified that actually subscribe our newsletters and subscribe maybe also the Eventbrite websites if you want to know of future webinars in the topic. Without further ado, Valeria, the floor is yours.
Okay, so thank you so much, Karen and Diego, and nice to meet you all, guys. Just before I start, can you please make it sure that screen recording is working? Because I don't know if I have everything enabled on my laptop. Okay, but it is working. Okay, good.
It is working, yes.
Okay, okay, perfect. Okay, because I just installed Zoom on this laptop, and let me close this window, otherwise I cannot see. Okay, so yeah. So again, thank you so much for having me today. As Chiara mentioned, I'm going to present some insights about human-robot collaboration and yeah, and what are the key factors to make it succeed and be more spread among people. Before I start, just a few words about me and my university, since I'm new to the society, so I think, yeah, you don't know me. And I'm from the University of Modena, Reggio, Emilia in Italy, and which is probably, you might know Bologna, which is the largest city nearby, and then I'm from, yeah, my university is from two cities that are nearby Bologna, so in the northern parts of Italy. And within the university, I'm in the arts control research group. Sorry. So I'm within the Arts Control research group, where Arts Control stands for Automation, Robotics and System Control. So we are mostly involved in different research topics around robotics and automation, and starting, I mean, ranging from control of these systems to the simulation and predictive maintenance, and also to the presence of human beings working with these systems. And this is, yeah, where it comes to me. So actually my background is not as a roboticist. So I studied as biomedical engineer, and my PhD was in biomedical engineering, in particular in signal processing. And then actually by chance, I joined this research group, which, as I said, is mostly involved in robotics and automation. So basically, I brought my background, which was from a different point of view, and we started investigating together with my colleagues the presence of human beings working with complex systems. So that's why my research goals, my research interests are in the fields of human-machine and human-robot interaction. So how to shape the interaction and collaboration of people with complex systems, and how to shape them around users' needs and capabilities. And so within this general presentation, the topic of today is about human-robot collaboration, and in general about the opportunities that collaborative robotics has introduced in practice. I don't know how familiar you are with the concept of collaborative robotics, so I'm going just to introduce it briefly. And actually, it's something that became quite popular in the recent years, basically because collaborative robotics and this paradigm was one of the main pillars of the Industry 4.0 paradigm. And so it has been experiencing a large growth in the recent years, and it is expected to grow even more in the next years. And basically, the idea of collaborative robotics is indeed that robots should collaborate with human subjects, and they should form a sort of team where they work together. And so they not just share spaces, so they are not working on different tasks in the same space, But in the fullest implementation of collaborative robotics, we have that humans and robots work together and share not only spaces, but also tasks and goals. So they work together at the same goal. There is no competition among them, and they are just pursuing together the same goal. And the reason why this paradigm seems to be successful, or at least in theory it is successful, is that humans and robots have different capabilities where they are best at, and so if we put them together to work together, then we can assign to humans and to robots those tasks that are more difficult to be attained by their counterparts. So typically robots can be in charge of physically demanding or repetitive tasks that might require high precision or high speed. And while humans are typically put in charge of those tasks that require advanced reasoning capabilities that are difficult to be implemented in robots with so-called artificial intelligence and so on. So this is the reason that has promoted the use of collaborative robotics, this idea of letting them complement each other's capabilities. And in order to make this become practical, most of the work, most of the research initially focused on safety issues, because of course, if we have robots working close to humans, then this collaboration has to be safe for the human. And on top of that, the need for implementing like smooth collaboration or successful collaboration has been recognized and has become a wide topic of research. So we can see collaborative robotics as the most the level of interaction between human and robot that is the most complex to be achieved, let's say. So in almost 10 years ago, yeah, it was 10 years ago, De Luca and Flacco, they introduced a nested framework presenting the different levels for interaction between a human and a robot. And the starting point was having them or allowing the presence of a robot nearby a human and allowing it to be safe. So the starting point for all of this work was avoid any collision and detect any physical collision between the human and the robot and possibly react accordingly. Building a little bit on top of that, then it came the turn of coexistence, which was the first level, let's say, of collaborative robotics. Still, it's not collaboration, but with coexistence, we just are assuming that robots and humans can share a workspace. But this was an important achievement and an important improvement or an important change, considering that before that, robots were were allowed to work just in cages, far from and humans had to stand far from them. And so this is the typical scenario of industrial robots, which is actually in practice in some industrial applications where we can see that we have these huge and dull robots, and any presence of the human in the area where robots are working is prevented. And from them, we moved to, with collaborative robotics, we are moving to a very different scenario, where, like the one in this picture, where we have indeed coexistence and we have physical interaction between the human and the robot. But still, this might be not enough for collaboration. I mean, that's not such an advanced collaboration, because actually collaboration requires something more, requires that, I mean, if I'm collaborating with a colleague, then we are coordinating our actions and our intentions. And as I mentioned before, we are working together at the same task with the same goal. So we are coordinating each other. And this is like the last step or the most complex step in order to achieve a fully collaborative robotics approach or system. But as I said, the starting point has to be safety. And in particular, in the use, regarding the use of collaborative manipulator arms, like the ones that are sketched in this picture, the standard ISO 10218 sets a set of 4 safe collaborative modes that can be implemented or that have to be implemented in order to allow allow a human and a collaborative robot to work together. So the first one is like the safety rated monitored stop, and basically it's quite a very low and simplistic level of collaboration, because simply with this level of safety we are just saying that the human and the robot can be in the same area but not at the same time, or if the robot is moving, the human cannot be in that area, and vice versa. If the human is moving, then the robot has to be stopped. So they cannot be active together at the same time in the same area. So that's not pretty much of a collaboration, and it's even less than a coexistence. So the second level, the next level that builds upon the first one is hand guiding, where in addition to the constraints of safety rated monitored stop, we have that if the user activates a specific command, then they can move the robot directly in order to teach them some positions. So in normal conditions, this level consists in safety rated monitored stop, but still it allows, this level and guiding allows the human to interact with the robot, so to move the robot in the environment by activating a specific command. And the goal is that of teaching the robot some specific positions. Level number 3 is the so-called speed and separation monitoring, where we have the human and the robot that can be active together, that can move together at the same time in the same space. So it's deleting most of the constraints of level 1 collaborative mode. And the way we prevent or the way we guarantee safety in level 3 is that when the user gets too close to the robot, then the robot slows down a lot. So we have these different 3 areas that connect the distance of the human from the robot with the speed the robot is moving. And the last step, the last level, which is the one that allows more like freedom to move and to collaborate between the human and the robot, is power and force limiting, where this is the mode where truly the human worker can work side by side with the robot. So they can be close, and they can exchange some interaction forces. But thanks to the presence of some specific sensors, collisions are handled. So that's why that's how safety is guaranteed. So these are like the 4 safe collaborative modes that guarantee safety in collaborative applications, from the more restricting, like level 1, to the one that is enabling more collaboration between the human and the robot. And these collaborative modes, as I said at the beginning, they represent like the standard point, the condition sine qua non. We can have collaborative robotics. And then on top of that, we can build some more advanced, like let's say some more advanced collaboration between the human and the robot. And as I mentioned before, allowing collaboration implies that, or looking for collaboration better, implies that we have the robot and the human that can understand each other's intentions, and so they can coordinate their actions accordingly. And in order to achieve that, an important part is to provide some proper human-robot interaction. So basically, human-robot interaction consists in making the interaction with the humans, not yet the collaboration, but just the interaction between the robot and the humans, so make it as intuitive as possible. And why is that important? It is important because if interaction is bad, no matter how sophisticated the robotic system is, then the poor interaction would cause like a barrier to the use of robots and would decrease the performance of interaction. And at the end of the day, people would be unsatisfied towards robotic technologies, and so they would prefer not to use them if given the opportunity. So poor interaction again is, proper interaction is one of the keys to guarantee proper collaboration or to guarantee successful collaboration. So let's say if we try to put them in order, we must have safety first. And if we want to get to collaboration, to successful collaboration, then it is important that the interaction is smooth and is intuitive. So then the problems becomes how to make the interaction with robots as intuitive as possible. And here in this slide, we have a list of different strategies. So it's not exhaustive, but at least it's a starting point, let's say. So first of all, if there is any need to program robots, then this is an area where intuitiveness could be improved. And on the other side, once the robot is programmed, then there is a constant need for the human to exchange information for the robot, so to communicate and provide inputs and receive outputs from robots. And this is again another area for improving human-robot interaction. And let's skip to the last one. Another way is like to exploit or to leverage reality enhancement techniques like augmented reality or virtual reality to simplify the interaction, to make it smoother. And last but not least, trying to adapt the interaction to users' needs. So these are some possible strategies to make the interaction more intuitive in order to achieve a more successful collaboration. So I'll go quite quickly through all of them. Let's start with the programming approaches. Classical programming approaches require the use of the teach pendant, which is like this human-machine interface that comes with collaborative robots, and it has its own programming language. So it allows to do a lot of things with robots, but it's not that intuitive, and it requires some experience and some expertise by the person who is using it. And another approach is like offline programming, where basically the same thing is done offline. It's like from engineers in their office, where they program like with computer-aided manufacturing or software like that, where they program, they pre-program the robot and can implement very advanced functionalities and working modes for the robot. But again, this requires a lot of time and a lot of expertise from the person in charge. And we are like here with these two approaches. So we can do a lot of things with them, but for sure they are not intuitive. And on the other side, if we want something that is like more intuitive, that almost everybody can use and that can be used to program robots in a quite quick and smooth manner, then is the turn of like walkthrough programming and programming by demonstration, where basically you move the robot around in the space just to teach and to show it the trajectories you want to go through, as you would do with a friend or with a colleague when you show them how to perform a task. So you show them and they learn, and then they are able to reproduce. And basically that's what you can do with robots by means of walkthrough programming and programming by demonstration. So quite intuitive, but then if you want to do something quite complex, then you might experience some limitations. So once the robot is programmed, then there is a constant need, as I said, to exchange information with the robot. And here the classical approaches and the initial approaches are using a keyboard, using a mouse, and possibly introducing, providing input to the robot in using its specific codes and its specific language, which of course is not that intuitive. And a lot of research has been done in that direction, basically trying to reproduce the way humans communicate among each other. So using gestures like the one in the videos with pointing gestures, using vocal commands, possibly based on natural language, and using eye tracking and facial expression and also haptics. So these are all ways to communicate to the robot, to tell the robot something in quite a, let's say, natural way for the human. And then it comes to like reality enhancement. So I mentioned also using augmented reality and virtual reality in the collaboration between humans and robots is something that is quite useful, since basically with augmented reality you can like enhance the real world with some virtual elements that increase human situation awareness and that provide additional information to the human in order to better understand what the robot is doing or what it is going to do. And on the other side, with virtual reality, or virtual reality is a good tool to let people get trained and get used to the use of robots. So they can practice a lot by means of virtual reality without any risk of damage and causing damage to themselves and to the robot, and yeah, without basically any cost. So these are some tools, some technologies that can turn very useful for enhancing collaboration. And the point that I left at the end was adaptive interaction. So what is the idea behind that? Again, it takes inspiration from the collaboration among humans. So if there are two people that are working together and one of them is like feeling more tired or more fatigued, and then the second person, if he's not, I mean, bad, or if there is not any competition between them, so the second person will try to get in charge of more work to be done and try to compensate fatigue from the first person. And this is the idea that we could borrow this idea and implement in human-robot interaction in order to make it adaptive. So in order to make the robot more or less autonomous, or changing the behavior of the robot depending on how the user is feeling. But in order to achieve this goal, we need to go through very specific steps. So first of all, we need to understand how the human is feeling. So it is important to be able to measure human capabilities and their current status. And once we have this information, then it is possible, then we can start thinking about how to adapt the interaction and how to make the robots help like the human person, and yeah, become more responsible or become responsible of more work that the person cannot be doing. And additionally, the robot could also provide some specific support in the case the human subject needs it. So adaptive interaction, it's not just adapt the interaction, but it requires some additional modules. And the way I've been doing that, or together with my colleagues, is resorting to affective robotics. So basically, what we try to do is try to recognize humans' affect and humans' condition and use this information to enhance the interaction of the human with the robot. And in particular, a crucial part of this consists in getting some feedback or some information from the human about their condition, like in an implicit manner. Without having to ask them how they feel. And as a result, as I said, we can change the behavior of the robot depending on this implicit feedback or implicit information we get from the human. So the first step, then it becomes like building a model of the human that is reliable enough and that collects all the important information, all the information that is relevant for interaction. So their capabilities, their emotions, their fatigue or workload. So just the information that is relevant for the interaction, and it should go in a human model. And the human model then provides like the inputs for the implementation of some assistive strategies that depend on the status of the subject, but also depend on the kind of task. So if the user is fatigued or is stressed, then the assistive strategy depends on what the human-robot team has to do. And based on this information, we can choose how to adapt the interaction. And as for providing some additional support, as I said, either virtual reality for making the human more familiar with the interaction system, or using augmented reality while using the system. So these are the options that we have been investigating. So I will not go through these three different dots, but I would like, if I have some time, I would like to add something. And actually, no, not the video. I forgot to, okay, so the video is enough without audio, sorry. Okay, everything is nice. Collaborative robotics sounds promising. We can complement each other's capabilities, and it's something like very trendy and Industry 4.0, 5.0, yeah, adapting interaction, okay. But are we sure that this is like always the good solution? That in any case where we can have the robot supporting the human, are we sure that this is the right direction where we should go? So it's like a provocative question, actually, but it's just to introduce a study that we conducted quite recently, and it was about exploring like the prerequisites for a successful human-robot collaboration. And the idea was that I mean, we always give for granted that robots should be working with humans, and our efforts are in the direction of making the interaction intuitive. Okay, but then let's take a step back and let's try to understand how people perceive the interaction with the system. So how they react to the interaction in order to understand whether providing the interaction or providing the use of robotic system is the right solution. And in order to try to give an answer to this question, we investigated how humans collaborate among themselves with respect to the human-robot collaboration. So we set up a study where we investigated human-human collaboration with respect to human-robot collaboration. And actually we implemented a quite simple task, which was a cooperative shape sorting task, where we designed these, this box with these perforated slots, and we have some shapes that were matched in shape with the slots, and some other shapes that were not matched with the slots. And we had either a robot or a human ending such shapes to test participants. And we explored whether there are some differences in the collaboration with a human, so the HH condition, and with a robot, so the HR condition. And okay, let's skip the details of the experiment, but we had 22 people participating in the study, and this was the setup. So this is the box. These are shapes. In the figure, in the picture, we have the robot, and so this is the human-robot collaboration, the human-robot condition. And in the human-human condition, we had another person standing here in the place of the robot, while the test participant was standing here. So yeah, so these are the details about the task. So basically the robot or the human picked a shape, put it on this pad, which was sensorized, and then the test participant picked the shape from here and put it in the shape sorting box or in this box for discarded pieces in the case of non-matched shape pieces. So we measured like the execution time and also the errors people made, and we also had we collected some individual feedback, and this is a summary of the results we got. So regarding errors, what we found was that in the human-human condition, people made more errors than in the human-robot condition. And also in the human-human condition, they moved quite faster. So we carried out this study with some psychologists from our university who helped us to interpret these results, and merging these results also with the feedback we had from people. We found that a possible explanation for these differences in the two conditions is that in the human-human condition, in the human-robot condition, people felt that they were working with a non-intentional agent, and so they were more attentive and cautious. And the opposite happened in the human-human condition. And also they perceived the human-human condition like more taxing, because there were another person who possibly could judge them. And also from subjective feedback, we also, people confirmed that they found working with another human more competitive. So that's why they were faster and made more errors. But still, and this is the interesting part, they judged the human-human collaboration more pleasant and a more positive situation than working with the robots. And so this was like a preliminary study, but the first take-home message that we can get from this study is that the need for human-robot collaboration scenarios should be considered depending not only on costs and the kind of task and the utility of the robot, but also on human attitude, because that could largely influence the performance of the task thoroughly. So, no, this was, sorry. So just some concluding remarks. I think I ran almost all my time, but at least we can have some discussion after, I hope. So some concluding remarks. Collaborative robotics is continuously growing, and it's becoming something more popular every day. And this is also because robots are also entering our daily lives. So in the presentation, I didn't mention it explicitly, but I was mostly referring to the use of robots like in working scenarios, but actually the trend and partially the current reality is that robots will become part of our daily lives, like providing social assistance, surveillance, and also for rehabilitation and search and rescue, and a lot of other applications. And so how to improve their use and how to to make the use of robots more successful. And then what I pointed out was that safety, of course, is like the first necessary condition. So it's always on top of the priority list, and no doubts about that. But then it is important also to provide an intuitive interaction, because it facilitates the use of robots and their diffusion, especially in everyday lives with general public, let's say. And then to make collaboration fruitful, it is important also that the robots can understand humans, and this is meant in sense of their current status. So if they are engaged in the interactions, so if they're paying attention, if they're tired, and so forth, so on. But also it is important that there is also an understanding of the user's intentions and behavior, and as well the user, the human, has to be able to understand what the robot is doing and why it is doing that. So there must be this reciprocal understanding between humans and robots. And the last point, I didn't mention it in the presentation, but it's becoming crucial. So it's social acceptance. So what about social acceptance of robots? In the last study, I showed that human attitude might be something important to look for and to consider in the use of robots, but still there is a lot to be understood in that field. So I think that's all from my side.
Valeria, thank you. From my side, and from Diego, and from the audience, I believe it was a very good, comprehensive overview of many of the area, and the area that are promising, the area that are still crucial to be developed further. It's really, really good. Now, question from the audience. We have room. We have room only for few minutes. So, guys, if you have any question, I suggest speak up now or hold your peace forever. So. Not forever, because Valeria was very kind to share with us also her contact details, but you are free to unmute yourself and ask the questions, even open your camera so that you can interact directly, or if you are shy or prefer not to do so, you can write your question in the chat box and we'll be able to relate that to you. In interim, I know Diego had a question.
Yes, I do. Thank you very much, Valeria. It's actually very interesting what you were saying about the interaction and the prerequisites for the successful interaction between the human and the robots, because there is this level of trust that I think needs to be built in order to let the robot and the human being assisted by the robot, and in order to grow this collaboration. But so I think there are some points to work on, and basically how to increase this level of trust. Is it by implementing more sensors that can predict, give more input to the robot and get more information from the human, and from there react? But then we have also the point of how invasive is that approach. So I don't know if you have a comment on that. How is the trust that can be built around the robots.
Yeah, that's a good point, Diego. And I don't have a clear opinion on that, actually, or I mean, but because my personal feeling is quite opposite to what is commonly done. So there must be something wrong in my personal feeling. But as you said, yeah, and as far as I know, the standard approach for enhancing trust is providing like more robots, and also the concept of more sensors, sorry, or also the concept of transparency, where the human knows what the robot is doing and can like understand why something went wrong and stuff like that. But I think it's like quite restricted and limited. I mean, if I trust another person, it's an open question, let's say. So is that just because I know how they are going to behave like in the future? Or I think that there is something more, but probably it's something that it's quite difficult to be disclosed and to be implemented. So that's why so far people are working on adding sensors and transparency. So on the like more implementation side, more the technological side. But to me, the word trust communicates something quite more extensive that goes in the field of psychology or whatever. So I don't know. I mean, I'm like a bit skeptical about that. So
I'm too. Like, can I comment on this? Because I think trust is part of the basic human experience that comes with experience. It comes with repeated signs lived through. That you learn to trust something or a person by spending time with that something or with that person and becoming accustomed to that reality. And I think we're no difference in this. Like, we need to learn, like if we embed the training as part of outreach programs in the schools. In fact, kids have less problem of trusting a robot than potentially than older worker might have. And it comes with just exposure and repeating experience that have a positive outcome. I think it's just not something that we can avoid. We need to have that type of exposure to be able to rely on.
So probably some social factors that can influence this, no? Because in Asia, maybe for example, in China, they're more they trust more, like they're more open to share their personal data in order to get more kind of facilitate more their lives. Just using one device, and then all the system knows how to react. But then the European focus is more towards protecting that data.
But that's not, that's part of the issue. But I think it's more about actually human experience. What we were saying, it wasn't sharing of data.
Right.
Quick question: is there anyone else from the audience? I know some names in the audience of people that are working in that topic. Any of you that have questions for Valeria? Philip, Chakra, Ayush. Guys?
Hello, can you hear me, Chiara?
Loud and clear. Hi, Philip.
Oh, sorry. Hi, how's it going? Thanks for the great talk, Valeria. I'm just wondering, in your experience, have you come across many use cases of human-robot collaboration in industry or elsewhere? And do you think that maybe the breakthrough for human-robot collaboration will come not through industry, but through service robotics?
Yeah, I mean, there are quite, or it's not that difficult to find examples or use cases of human-robot collaboration in industries, and also because like the industries have also like taxes reduction, I don't know the word. So robots are being used and collaborative robots are being used, but is that really collaboration, or is just a basic pick and place task performed to make the human like more stupid and getting even crazier around the robots. So yeah, in theory, there are, it is possible to find a number of use cases, but in practice, I would question that that's not exactly the human-robot collaboration I mentioned at the beginning, where there is like robots doing silly tasks and human performing intelligent tasks. So that, I don't know, I mean, I should think whether I've seen any of those examples with this like intelligent division of tasks. And probably in like with service robots, so in daily lives, then it is more difficult to keep this collaboration so simple, because everyday life scenarios are so like complex by default, so we cannot simplify them and put all the difficulties on the user as it is typically done in industries. So probably that will be the place where the approach will change, but not that much in industries. So.
Valeria, would you consider remote operated vehicle an extended concept, including robotic? Because if you consider that, then in oil and gas, certainly there are tasks where there is a true collaboration of giving access to places that are prohibitive or environmentally prohibitive for human to access, and being remotely operated by an operator that does the intelligent task of what needs to be done through a robotic arm that can reach a place that would be, let's say, unreachable for a human, or the search and rescue tasks, if we consider some form of automated vehicle as an extended concept of robotic application. I think there are some positive experience without having to invent a silly task, like you were saying. There are places where this is already a reality and a useful one at that.
Okay. Yeah, that's like a complex scenario where it makes sense to have.
There was a comment in the chat saying that, you know, thanks for the very interesting presentation. We wholeheartedly embrace the same. We keep normally the lunch and learn within the hour so that we won't impinge on anyone else's other activities after, but this was very useful. Thank you for letting us record it as well and make it available. And Valeria, we hope to see more of you.
Yes, sure. We will.
Okay. And there will be thanks in the chat for you, Valeria, I'm sure. And guys, for everyone, if you have a suggestion about other topics that you like for us to explore in the future of the Lunch and Learn webinar, feel free to suggest them in the chat now or by reaching out to us, and we'll do our best to bring to you valuable experience like the one that we shared today. Thanks again to everyone, especially Valeria, and we'll be in touch in a month from now for our next webinar, which is likely to be on the experience of users on new design of aircraft.
Yep.
Okay.
Sure. All right. Thank you very much, everyone, and see you next time. Bye-bye.
Thank you. Bye.
Thank you, Valeria.